Okay, so I will share my screen. First of all, thank you very much for giving us a chance to present our work to you. And I hope that it will be the start of a cooperation, an active cooperation with Belize in this topic of tsunami warning, maybe also earthquake information. We would be much interested to get into better cooperation with you in Belize, because some parts of the seismicity north of Honduras is not very well controlled by our monitoring system. And to get a better constraint of the locations of the earthquakes, and also for the simulation and determination of parameters of possible tsunamis, we would like to have some seismic stations east of this seismicity. That means actually in Belize. As I know, in the moment, there are no seismic stations there. And maybe we could together search for possibilities to install some. Well, we will later on have some maps where we can show you the situation. And I hope in the near future we could have other meetings and maybe even visits to improve the situation. Well, now I'm sharing my screen. It's a little bit slow, my machine. I don't know why. Okay, you should now see the PowerPoint. And so let's start. This webinar was organized by the initiative of CATAC to support the third regional exercise we will organize in June this year in Panama, a regional exercise on the actuation in case of a big disaster. So, and we were asked to participate and to give more information about our work to the Central American institutions, which are the recipients of our products. That means seismological institutions and institutions working on civil protection. And CATAC also asked us to include in these sessions institutions from Belize and also from Dominican Republic, because we are getting into more cooperation with these two countries for the simple reason Belize is very near. It's a part of Central America, and events which affect Central America might also affect Belize. There might be big earthquakes which could originate tsunami in Belize. On the other hand, in the case of Dominican Republic, it's a Spanish-speaking country and is surrounding of countries which are mainly speaking English or French. And they are also seeking to contacts with Central America. Both countries are integrating in Central American institutions as CATAC and SICA. So I would like to start with some general thought about the tsunamis. We have seen that tsunamis on a worldwide scale threaten the safety, resilience, and sustainability of nearly every coastal community on the planet. About 680 million people are living in the moment in low-lying coastal areas. That means 10 meters above, less than 10 meters above sea level. And they are exposed to varying degrees to tsunami risks. This number is expected to increase to more than 1 billion by 2050. Between 1992 and 1919, nearly 300 confirmed tsunamis were observed worldwide. 35 caused loss of life. And we all maybe remember the 2004 Indian Ocean tsunami, which claimed nearly 230,000 lives in 14 countries and caused nearly 10 billion worth of damage. People in 2004 were not at all prepared for this tsunami. There was no organization in place in the Indian Ocean to warn the people. Though we had the information, there was the information in the tsunami warning center in Hawaii. The Hawaii center tried to phone the governments in these countries, which would have the impact of the tsunami. They phoned in time before the tsunami could arrive the country, but there was simply no preparation. And this was a very strong thing to think about how to improve tsunami warning all over the world and in all the regions. Well, this agenda is very detailed. It was to prepare ourselves. I would like to present first some information about hazard and risk of tsunamis in our region, then how CATAC was invented, we can say, and developed. How is the situation in institutional situation of CATAC in Nicaragua and Central America? Which products are generated, elaborated by CATAC in real time, and how we want to work in the capacitation and information to the countries. Then we could also see some possible situations of tsunami for Belice, and also some information about the products of CATAC could be used actually in Belice. Well, I mentioned that we will have this simulation or training in Panama in June this year. The hypothesis in this case will be that an earthquake of magnitude 7.5 occurs very near to the city of Panama, with an epicenter located in a fault which crosses actually the Panama Canal and might affect also the structures of this important thing in Panama for the economy and for the people. There will be damage, of course, to human settlements. Panama is a big city with high-rising building. Many buildings are new, hopefully well constructed. Others are old and might suffer destruction. There will be trapped and missing persons, structural fire and hazardous material spills. Additionally, there will be also training for meteorological phenomenon, a tropical wave which is crossing supposedly Panama, and also a biological disaster, contamination with a monovirus. Well, Panama thought they were not prepared to include also tsunami exercise within this simulation. So it was not included by CATAC, but we were thinking, CATAC, we were thinking that we could do some meetings in Panama during the exercise and discuss with the Panamanian colleagues and friends how to improve the situation in this respect in Panama. And in the next slide, I show you the agenda of our webinar. So we started in February already with the first meetings in Nicaragua, which were not by Zoom, of course. We went to the institutions of civil protection we have in Nicaragua, CINAPRED, which is the umbrella institution for prevention of disasters in Nicaragua, and civil defense, which is a military institution. Then we went to El Salvador, Guatemala, Honduras, and later on in March already, Costa Rica, Panama. Yesterday we had a meeting with the Dominican Republic, and today we are here in Belize. At the end, we will have also a meeting with CATAC to present the development of CATAC, but also to have some first evaluation of the ideas and discussions we had in these meetings. But let me explain a little bit with whom you are speaking. I'm working at the Instituto Nicaragüense de Estudios Territoriales. It means the Institute for Territorial Studies. It's a little bit strange name. In reality, it's the Geoscientific Institute of Nicaragua. It was created in 1983 when they put together a number of smaller institutions which existed in Nicaragua. For instance, the Institute for Seismological Studies, which was created just after a big earthquake destroyed Managua, the capital of Nicaragua, in 1972. Other institutions about meteorology, geology, physical cadastre, all of them were unified, were put together, and now we are a rather big institution. I think the biggest institution of this kind in Central America. We have about 400 people working with us in the scientific areas of geophysics, meteorology, water resources, geodesy and cartography, physical cadastre, geoinformatics. Well, so tsunami for us is a phenomenon which has to do a lot with seismology, because it is mostly caused by earthquakes. That's why in Nicaragua, the tsunami warning is at home in the seismology department. This is part of the geophysical area in the INETER. You have here the photo, an air photo of Managua, and there you can see the area of INETER. It's similar to a campus of a university, so some buildings, and you can see a little red point maybe in the left part of the photo, and this is the site where seismology is located. In the moment, there are about 20 people working in seismology for seismic monitoring, studies, investigation, projects, earthquake monitoring, tsunami monitoring, and earthquake and tsunami early warning. The CATAC as a topic is attached to the director of INETER. So I'm subordinated directly to him. I'm working as an advisor at the institute, but I'm also advisor to the government of Nicaragua about topics which have to do with disaster prevention, earthquakes, tsunamis. I represent Nicaragua in international meetings, in the meetings of UNESCO, in the tsunami warning system of the Pacific and the Caribbean. I'm at the moment the vice chair of the Pacific tsunami warning system, and I worked about 5 years as a chair of the system, so I know rather well and with details the problems of tsunami warning in the Pacific area. I visited many countries. I also worked in the Caribbean system, and I'm part of especially the working group for instrumentation, monitoring, seismic, and sea gauge monitoring. So we have very close contacts with UNESCO, and the development of CATAC had a lot to do with the orientations of UNESCO. Well, below you can see the Dirección de Sismología, Directorate of Seismology. So in the organigramma we are divided, but in reality it's one unit. So, well, then in Nicaragua we have an organization for disaster prevention, which is rather big because it includes contact persons in all important institutions, ministries, universities, the local and national governments, schools, the firefighters, and many institutions really. That means a large number of people are integrated in this institution. But the secretariat of SINAPED is rather small. It's about 30 or 40 people here in Managua, which lead this umbrella organization. So we can make use of their contacts for the messages we are elaborating. We can send them to them and they distribute them, or we can send messages directly. We can also ask for cooperation if we want to make a capacitation somewhere. Then we have another institution, which is civil defense of the Nicaraguan army. This institution is much older. It has its history now of about maybe 40 years or so, whereas CINAPRED was established in 1999. Well, INITER is the third leg of this group of institutions for disaster prevention. So we are really working very closely together. We know our partners and these two institutions very well, are doing common capacitations, are doing common work in the field. And we are also cooperating in the international projects we have. Well, let me now mention how UNESCO has organized the tsunami warning system on a regional scale. Well, the example of Nicaragua, for instance, is the countries need somebody who provides the information about a possible tsunami, who's monitoring the earthquakes and the sea level, and if there's indication for a danger, should emit a timely tsunami forecast. Some countries have a known service to do this, and many countries do not have. So in Nicaragua, we have such a service since 1996. So we were working for many years with our own national seismic tsunami service provider, which is INITER. So that means the center that monitors the seismic and sea level activity. Then the country should have a national tsunami warning center. This warning center receives the data, the scientific data about earthquake and tsunami threat, applies this data to the case of their country, and issues tsunami warning to the institution in their country. Well, in our case, it's INITER for many years already, and now we have CATAC, which is both a regional and a national tsunami warning center. So I guess in Belice, it's you. In another organizational point is a tsunami warning focal point, which is Nicaragua, CINAPRED, and civil defense. So they have 24/7 offices. They are points of contact. They receive the messages from Hawaii and from us, of course, and distribute them and also organize countermeasures in the affected areas. And finally, we have a national tsunami contact, which is officially the director of INITER, but in reality, it's me. So I'm actually the person designated to work in the intergovernmental coordination group for the Pacific and for the Caribbean, represent Nicaragua in the coordination of the international tsunami warning and mitigation. On the other hand, also to pass the information from these organizations to Nicaragua. Well, I guess I have the organization structure for Belize, but I had no time to put it on the slide. So I guess you know exactly how it is, and I don't need to put it here. Maybe in another occasion, it would be interesting to know how you are working and how you get the messages and how you distribute them. Well, I have to record a very traumatic event we had in Nicaragua. It was a disaster tsunami on Nicaragua's Pacific coast on the 1st of September, 1992. occurred in a magnitude 7.8 earthquake in the Pacific Ocean off Nicaragua. It was a very strange event. I was in Nicaragua at this time in Managua. We didn't feel anything. I was observing this night. It was at about 7:15 in the night. It was dark already. There was a mirror in the where I was, and big mirror, and this mirror started to move slowly. It was on the wall, and it's moving slowly. And I was, it was strange, very strange. And I was recalling a similar event I experienced in Germany 20 years before, when we had also similar things, pendulums moving, mirrors, lamps, and so. And it was by an earthquake in Italy at a large distance of about 600 kilometers. So I remembered this, and I thought, let's go to the office. What is going on? In this time, Nicaragua had no seismic network. I was actually in Nicaragua to help to build up a seismic network. So I was coming from Germany. Well, I went to the office. We had one seismograph working there, and the ink recorder was working like crazy still. And it was distributing the ink not only on the paper, but in all the office. So strong was the movement. So I knew something is going on, but you couldn't feel it because the seismograph is very sensitive and can record also frequencies which we cannot feel. So it was strange. Where was this earthquake? We had no network at the time. I couldn't locate the event. We had no telephone in this time at the office. You remember Nicaragua in the 80s was in a complicated socioeconomic situation. So the country was in a very bad situation. Then I went to civil defense to ask them, and they, by car, and they didn't know nothing. I returned to the office. When I came in the gate, somebody has a radio, and I could hear shouting people, and somebody speaking about inundation in the Pacific coast, and so this was my first meeting with the tsunami. A very strange tsunami because this was a slow earthquake. These are earthquakes which generate tsunamis, but do not generate nearly nothing on seismic energy, which we could feel, and frequencies we can feel. Well, so it was causing a huge confusion. Nobody was expecting this. Nobody was prepared for this. There was no preparation or any warning in Nicaragua, neither in all Central America. Well, later on, other tsunamis in Central America. In 1991, there was already a tsunami, but a not so big one, the Caribbean coast of Costa Rica and Panama. The 1992 tsunami I mentioned. The 2009, there was an earthquake north of Honduras, and it generated a small tsunami in the Guatemalan coast. In Honduras, I guess also a small tsunami in Belize. 2012, there was a tsunami in the Pacific coast of El Salvador, Nicaragua, with 5-meter waves, fortunately affecting only areas with very few people. Nobody died or was affected. You can see in the photo in El Salvador, a person indicated to which height the water affected this house. A similar height we could see in Nicaragua, and people indicated as the same. Well, this map gives the main causes of earthquake and tsunami affecting Central America. It's the collision of the tectonic plates. The tectonic plate of the Cocos is coming from the Pacific Ocean. It's meeting the Caribbean plate, and we have very strong earthquakes in the subduction zone. These are causing the main tsunami threat for Central America. But also in the north, just between Honduras and Belize, we have these place where the North American and Caribbean plates meet and very big earthquakes. But fortunately, the movement of these plates is mainly horizontal. So that means they do not generate such strong tsunamis as we have in the Pacific Oceans. There's also a tsunami generating activity north of Panama, and smaller tsunamis can also be generated by faults which are in the Caribbean Ocean, and or even faults on land. For instance, just in the coastal area of Costa Rica, there are faults which could generate earthquakes. There's one place, the Gulf of Fonseca, which is shared by El Salvador, Honduras, Nicaragua, where we could even have tsunamis generated by volcanic eruptions, big volcanic eruptions. We have volcanoes there. Or volcanoes can also suffer a collapse of some of their flanks. The water, the landslides could enter the Pacific Ocean or the Fonseca Gulf and create tsunamis. Here you have the map of seismic activity in Central America, and you can clearly see the big and frequent earthquakes in the Pacific coast. And in north of Honduras, near to Belize, we have also big earthquake, but not so frequent like in the Pacific part. Well, in 92, when the earthquake and tsunami occurred in Nicaragua, we knew nothing about tsunamis in Central America. There were no publications. So we started the project financed by the Nordic Cooperation, Norway and Sweden. And there was an investigation, and after 2 years, in 1995, we had already a catalog of tsunamis which had occurred in the regions, and we found more than 50 events. You can see in this map the length of the red lines indicates more or less the magnitude of the earthquake or of the tsunami. The biggest was the tsunami of 92. Then there was a rather big tsunami north of Panama, 1882. Also in north of Honduras, tsunamis with more than 5 meters height, and smaller events in Costa Rica and the other countries. To the right, to see the indication of the height of the tsunamis affecting Central America. Biggest event, Nicaragua, with wave heights of up to 10 meters, and remarkable tsunami also in the 19th century in Honduras, and other big tsunamis north of Costa Rica and Panama. Well, this was actually the beginning of knowledge about the tsunami threat in Nicaragua. And this tsunami also changed the way people thought about earthquakes and tsunamis. And I have to tell you, in Nicaragua, people are have much more consciousness about tsunamis than in other countries of Central America. People here, when they go to the beaches, they always have in their mind, they remember If they are older, they remember the tsunami. If they are younger, they have heard stories about the tsunami. And people, they are afraid a little bit always when they go to the beach, especially to the Pacific Ocean. Well, we started Nicaragua to cooperate actively with the tsunami system of the UNESCO in '93. We became member of the system. We got information about the efforts, international efforts. In '96, we established the National Tsunami Warning Center in Nicaragua, including, actually, we were tsunami information provider because we had already a small seismic network. And actually, Nicaragua was the first country having an NTWC in Central America. 2003, CATAC decided about the development of a regional tsunami warning system, but it was not very efficient. There was a lot of discussion, but no concrete action we were taking. Now, 2003, the ICG PTWS created a working group for Central America to support this process. All countries of Central America participated, are still participating in this working group, and also some people from other countries, especially Japan, then are participating from time to time. The Hawaii data center and the Tsunami Information Center, ITIC, of the Pacific Tsunami Warning System. Then we had these big tsunamis in South Asia, 2004, 2010 in Chile, 2011 Japan, and these images impacted everywhere, and there was much more interest in the international scene, also in Central America, and people were seeking what to do against the tsunami threat. Nicaragua, we had many meetings at this time, 2009, 2011, 2014, we had meetings of the Central American Working Group. And finally, in 2014, Nicaragua, the government of Nicaragua offered the establishment of a tsunami warning center in Nicaragua at Ineter. Now I have also to mention another development which occurred in 2012, 2013. In these years, we had a very efficient project or initiative of a small private company which worked on seismic monitoring systems, seismic devices, were selling seismometers and so. This Panamanian institution learned how to use a software which was developed in Germany to help Indonesia after the big tsunami in 2004 to establish their tsunami warning system. And Germany developed a software package. The development of this package was done in the same institution where I was working years before. So I had rather good contact. And I started to work with this Panamanian institution, and we were able to learn how to use this package and then offered it to the Central American seismology observatories. It was very successful, and as soon as the software made it possible that the earthquakes were processed automatically. much easier than to do it manually, and it was possible to work much faster, to process more events, and the software has also capacity to distribute information, to get information from other countries, and to send own data to the other countries. Well, 2015, CATAC sent a letter to UNESCO where they recognized the necessity of the development of the Central American Tsunami Warning Center, which was proposed by Nicaragua, and of a regional seismic network to be established in the Republic of Nicaragua, and to include it into the SICA system for the integration of Central America. So this letter was actually the final step to create CATAC. CATAC was created by Nicaragua. Then we went to the meetings of the ICGPWS, the Caribbean Tsunami Warning System, and to the UNESCO General Assembly, which were in several meetings, and presented the CATAC, and the idea was accepted by this organization, and we could start to work on the development of CATAC. Well, here you can have a copy of the letter CATAC sent, and we had also big support from the seismological institution in the region. Here you can have a map of the places where we installed the SeisCom software. As you can see, in several places in Panama, there was one place is OSOP, the small company I spoke about, scientific knowledge about seismology, devices, and software. Another center, another software package was installed in the University of Panama, which is kind of national seismology group. And for the Canal of Panama, they have also a small seismic network. In Costa Rica, it was installed in 2 places, in 2 universities, in Nicaragua, at INETA, our institution, but also in civil defense. You can see on the right a photo where they have the software working. They got the information from INETA, the seismic data, and this was presented in real time in their code, in their monitoring center. So they got, and still we are working this way, they have immediate access to our results and to our data. So in Honduras, El Salvador, and the women, they were also installed software packages. Well, after creating CATAC at INETA, we were able to get support from Japan. We started a project with Japan. Japan has a lot of experience with tsunamis, and we worked together with the Meteorological Agency of Japan, which is responsible for tsunami warning in Japan, and also maintains a regional tsunami warning center for the Northwest Pacific, which includes all the countries between Russia, the countries from Russia down to, you can say, Philippines, Indonesia, so several countries. There were also other projects from UNESCO, and we had another project at the same time with Switzerland about earthquake early warning, EVA NICA. So these projects cooperated, and actually in 2019 we were able to complete the reinforcement of CATAC. We presented our advancement again in meetings of the PTWS and Caribbean EWS, and both organizations accepted that CATAC could start a pilot operation phase. And we are still in this phase. Though ICG PWS at the end of 2001 accepted already that CATAC is ready to start with the routine work, but remember we were in the area of the virus still, and so it was not really possible because we were not able to get the approval from the Caribbean EWS. And we are still waiting for it. There will be a meeting in April, and we will seek the approval. And from this moment, it should be possible for us to start the routine work. You can see here our group, mainly younger people. They are also in this photo, which is a bit, some years ago. They are the Japanese advisors. I have to mention to the right, you will see the academic level. So one PhD, which is me, then 7 people with masters. These people got their masters in Japan during the project. We have actually, in the moment, 4 people studying their masters in Managua at the university. Then 4 engineers, 1 licenciado, which is, what is it? Yeah, diploma, and 2 technicians. Well, here only a photo of the meeting of the ICG PTWS, which sent 63 representatives from the different countries in the Pacific area. This meeting was in Nicaragua, and we were able to show them directly our advancement, and we were discussing it with them. And it was for us a rather important step. Here I'm presenting CATAC at the General Assembly of the Intergovernmental Intergovernmental Organization of the Oceanography in Paris. There were representatives from about 180 countries, and I had to give a presentation of 7 minutes only because many topics were discussed. And we got the approval with 100% of the votes. Well, in the moment we have 400 seismic stations in Central America recording in CATAC. 140 from Nicaragua, about 100 El Salvador, about 70 Guatemala, about 10 in the moment from Honduras, 20 Costa Rica, and 20 from Panama. We have 2 watchstanders working 24/7 from a group of 16. So this is a work we had been done already just after the tsunami in 1992. So we established the system of 24/7. In this moment, only with 1 person. In 2019, we were able to start with 2 persons because it's too complicated. In the case of a big earthquake and tsunami, it's not possible to do all the work with 1 person. So we are doing the seismic processing first, then the evaluation of tsunami, initial message in 2 minutes, and message with more precise tsunami parameters in about 10 minutes. This depends on the location of the earthquake and of the size of the earthquake. Messages are sent to 11 scientific seismology institutions and 9 civil protection agencies and CPNAC. Well, you can see here the website of CATAC. Let me try to show you more in detail. So I have to change the, So you should see now the website of CATAC. Well, here you get a lot of information in real time. Let me enter in the seismicity viewer. While this is a map where you can see the earthquakes we detected in the last 5 days. We present here only bigger events. In Nicaragua, we are also detecting smaller events. So you can see here the map for Nicaragua, and for a global scale, we have a system which is also trying to detect bigger earthquakes all over the world. So the last event was 19 hours ago in the Dominican Republic. You can see some recordings, the data of the event, magnitude 5.2, depth 78 kilometers. So everybody can enter our website and can get this information and can know how we are working. We can also get access and see how the localization worked. Where is this event from? Dominican Republic is here. So, and you can see, seismologists can see details and can even make a relocalization of the event. But I think you have to for doing this, you need to give a password. So then we have the seismic stations. And you can see here the network we are using. So Nicaragua has each triangle represents a station. We have different kinds of stations. Short period seismic station, broadband station, and accelerometers. And you can see also in the Caribbean, the density is smaller because we do not need so many stations for processing the tsunamis, which could be generated in this region to get to us. So we have more time. We do not need to do it so fast as we have to do it for earthquakes which occur in the Pacific. And on the world, we have also some stations we get data from for other regions of the world. Well, here we have the user's guide of CATAC. This document was elaborated in 2019. It will be improved in this year. List of publications, information about tsunami simulation we organized in 2019 and 2020, and some documentation about the software. So we will try to improve this website, and I will go back now again to the presentation. Okay. Well, you can see here a map of the seismic stations in Central America. It's a little bit old already. There are today much more stations, especially in Guatemala, Nicaragua, El Salvador. I would like to mention that Central America is one of the regions in the world where we have the highest density of seismic stations. That's because we have many volcanoes, active volcanoes, and for the monitoring of the volcanoes, we need seismic stations, and we need them also for the general seismicity. Only Costa Rica, for instance, has about 500 stations. They have 3 institutions which are using seismic stations, 2 universities, and in one university they have 2 organizations. One is for the general seismology, and the other is for seismic engineering. And both of them have seismic networks. So we could make use of them, but not always they are cooperating well. But anyway, it's a very good situation for us, for CATAC, because we actually get the information we need for tsunami warning. Here you have a view to our center. This is for the processing, manual processing. This is a meeting room and situation room. Here our colleagues are processing seismic events. Here is somebody looking to the simulation of tsunamis. I mentioned already the main software we are using. One is the SeisComp from Germany, and the other is Toast, which is a program which is compatible to SeisComp. It can make use of the seismological data, results obtained by seismological processing, and with these data, it can try to find out about the tsunami, which could have been generated. So it makes a numerical tsunami simulation, and it can also send out simulation product in messages, including arrival times, amplitudes, maps. It can also record, process recordings of tide gauges. So it's a rather complicated, complex software. Also, SeisComp is a complex software and a very powerful. How to decide about the possibility of tsunami? In the beginning, in the first minutes, we know not too much about the earthquake. We know where it started. We know the hypocenter, that's the point where the rupture and the fault started. And we estimate the magnitude of this earthquake. In the beginning, we don't know it very exactly, but we have an idea about the magnitude. If it's between 4.5 and 7, we would say in the beginning, in the first minutes, there's no tsunami threat. Later on, if we get a little bit more information, we can say it more exactly. If the magnitude is above 7.1, between 7.1 and 7.5, we speak about the possibility of the destructive local tsunami, which might affect areas and distances of between 100 and 300 kilometers from the epicenter. But the epicenter can change. You know, the epicenter, not the epicenter, but the generative area of the fault can change. You might think in the beginning it's near the epicenter, but after more detailed analysis, we know that's another point of the faulting process where the fault moved faster or with a larger displacement. And larger displacement means more changes in the sea level, in the sea bottom, and more possibility for a tsunami. So if the magnitude is very big, more than 7.6, there could be a destructive tsunami along the coast of all Central America. Depends, of course, where the earthquake is, if it's whether it's the coast of the Pacific or the Caribbean. If it's a very, very big earthquakes, and there could be even destructions in other areas of the world, but that's of course already work of the Hawaii Tsunami Warning Center, and they would give the corresponding information. In this slide, you see to the left the map with the areas we have to serve for. So that's in the Caribbean, of course, the coast from Guatemala to Panama, and the islands of Swan Island, Honduras, and in the Pacific we have all the coast from Guatemala to Panama, and there's also an island, Isla del Cocos, Costa Rica. The length of the coastal areas is about 4,000 kilometers. It's rather a large area we have to serve for. It's comparable with Chile. You know, Chile is a country with biggest tsunami threat maybe in the world. They have a coast of 4,000 kilometers, but they have more big earthquakes than we have in Central America. Mexico has a coast of 7,400 kilometers. To the right, you can see the area we have to monitor is delineated by these red lines. So in the Pacific area, it's between southern Mexico, Galapagos Island, and Ecuador. And in the Caribbean, the area between Belice, Yucatan, Cuba, Haiti, Dominican Republic, and northern Venezuela, Colombia, towards the coast of Central America. In these two areas, the earthquakes which occur, if they are strong enough, can generate tsunamis which arrive in Central America within 1 hour only. That means if it occurs in Galapagos, a strong tsunami, which is actually possible, even by a volcanic phenomenon, this would arrive in Costa Rica in about 1 hour. So I mentioned the seismic network. Fortunately, in the last year, we could improve the seismic networks in Costa Rica, but mainly in Nicaragua, El Salvador, and Guatemala a lot. Within the project for the seismic early warning with Switzerland, we got a donation with many accelerometers. You can see here these red triangles symbolize the location of the new stations. These accelerometers have the advantage that they do not clip in the case of a big earthquakes. Most other stations are not able to record very big earthquakes. They will have fine recording in the beginning when the amplitudes are still small, so we can use them for detecting of the first seismic waves. We can use them for location of the earthquake, but we cannot use them to determine the magnitude of the earthquake because they are clipping. And the accelerometers do not clip. They can record very strong movements, and they can record them in a very wide range of frequencies. So with these new instruments, we can work faster, we get results quicker, and we have also more data to determine the strength of the earthquake and later on the tsunami. Now, I would like to mention one topic. One important parameter for the threat of the tsunami, besides the amplitude, which have the waves when they arrive at the coast, is the timing. If it takes 1 hour for the wave after the earthquake to come to the coast, we have sufficient time, at least in Nicaragua, to organize the evacuation of all people on the coast. In Nicaragua, we have a lot of experience with this. But if the wave arrives 5 minutes after the earthquake, we do not have this time. So in this slide, the red areas indicate where tsunamis can occur very few minutes, 5 to 10 minutes, 15 minutes after the occurring earthquake. So you see near Belize, you have this area in northern Honduras, Guatemala, where the fault of Motagua comes close to the coast, enters Guatemala, and then continues until the city of Guatemala. If this fault presents a strong movement, a tsunami will be created in Guatemala, southern Belize, in a short time. Belize has the advantage that the water depth is very shallow. So you have a wide area and the tsunami needs more minutes than in Guatemala or Honduras. In Honduras, near the coast of Honduras, the water is deeper and the water and the tsunami moves according to the depths of the water. If it's very deep, as in the Central American Trench, with 4,000 to 5,000 kilometers, it's like an airplane, a fast airplane. But if it's shallow, as near the coast of Nicaragua, we have a very broad area of shelf, where the water depth is only 50 meters or 20 meters. It is very slow. The tsunami moves like a slow car, or later on maybe like a bicycle. So, but there in northern Honduras, it can affect the harbors in a very short time. The worst case is Costa Rica. Along their coast can occur tsunamis. And they have even along the coast faults, which also can generate tsunamis. That means they have very little time. Similar in some parts of Panama, and similar in the Gulf of Fonseca of Nicaragua, which I mentioned already. There can occur earthquakes of magnitude 7 and bigger, and the tsunamis would affect the population in a few minutes. These earthquakes could also cause a landslide in the volcanoes there, and this landslide would add to the tsunami hazard. So seeing this, we were not aware about this when we started with CATAC. In the last years, we concentrated us on this topic of the time tsunami needs to get to the coast, and that's why we are trying to accelerate our work. Well, how can we do this? One possibility would be to send out our messages faster and to use the new methods we have now for distribution of data or messages, the WhatsApp, Telegram. We could use also a strategy to increase the number of people who could get our messages directly. This is very easy with WhatsApp or Telegram now. And we are also thinking to develop an application for cellular phones to distribute our products, because some products are graphical, maps, recordings of sea gauges, for instance, and these maybe are better to be distributed using an application. About the methods of warning, we have in Nicaragua a good system. Along the Pacific coast, we have 60 sirens, big sirens, which are able to inform the people about the threat within a few seconds or minutes. They are centralized and are controlled by civil defense in Managua. So with their computer, they can select the sirens they want to activate, and the siren will speak to the people and will shout tsunami warning. And also is a typical siren signal, which can be heard up to several, in some places, kilometers of distance. In bigger towns, we have several sirens. In villages, only one siren. I have to mention, at the coast of Nicaragua, the Pacific coast, we do not have too much population. We do not have very big cities, mainly smaller settlements. And two bigger harbors for us. On an international scale, they are very small. And of course, we have also tourist centers. On the Pacific, on the Caribbean coast, we have now 20 sirens. And I have to mention that these sirens are also used for other threats, not only tsunami, of course, in the Caribbean side, mainly hurricanes. Well, let me have a small break now. I will get one colleague of us who will present about our messages. Just 1 minute.
Good morning. Do you listening?
Yes, good morning. I'm here.
Okay, thank you. My name is Emilio Talavera. I am director of seismology here in Nicaragua. I work here for more or less 25 years. I working in CATAC also with the Dr. Strauss. In this case, in the screen, do you have the preliminary message, automatic message, bulletin of the events, and few seconds after the big earthquake, for example, 4.5. This information is sent all the countries of the Central America. In this case, for example, in this example is in Spanish, but also we go to send this information in English too. But now this information is sent in Spanish. The first information is about the parameter of the events, the earthquake. In this case, the origin time, the epicenter, latitude, longitude, the depth and magnitude. And this is sent with some information about the tsunami, possible tsunami events. And for this event, for example, the event is in land in Costa Rica. The event was the 5.1. therefore no emit in this case advisory about the tsunami earthquake, for example. This is in all the countries in the Central America, since the Panama to Guatemala. In parallel, the seismologists on duty processing this information, and when this information is confirmed for the seismology, other bulletin is sent different countries. This information can be changed in some data, for example, in their depth or latitude, longitude, for example. But this information, in case the INETER, the CATAC, we have the responsibility to send this information in more or less 3 minutes maximum. If you want, you can make me some question, for example.
Not really. I don't have any questions right now. Thank you.
Okay. And now, Dr. Strauss.
Well, then we will continue with another colleague of us, Norvin Acosta, who will speak about the products of the toast module and the graphical and the simulation of tsunami.
Good morning, everyone. I'm trying to explain the function on this model. This model is some part of the SiteCon 3 and SiteCon 3 Pro. This model using for calculates tsunami high amplitude. This using the tsunami numerical solution easy way. The advantage of the easy way is the faster calculation tsunami high using graphical hardware to calculate very fast the solution. And in this case, this program or this model using the deformation, the calculator of the rupture of the fold using CATAC proposed, and this program using for calculate the tsunami amplitude weights in 2D, and these solutions is compared for different tsunamis numerical models. For example, the tsunami N2, N2, tsunami N2 from Japan, and the idea is this program is sense the different tsunami highs and different for forecasts.
Sorry, excuse me. Are you presenting something, because there's nothing appearing on the screen? It's only.
Oh yeah, but only introduce some.
Oh, okay.
Some data of the program.
All right.
Okay. Okay. Well, I go to show you the program, this model. Okay. Okay. Tools using or running on the Linux and system OS. Ah, and you can see the screen of the.
Yes, I'm thinking.
Okay. Okay. Tools using for input all solution from the cycle tree. Also, all solution can see can for the automatical solution calculate in cycle or manually solution or automatically or manually solution from the model of a moment tensor. In this case, you can see in the program can obtain different solutions for automatical, and the program using the if the program register some magnitude, for example, for magnitude 5 or 6, the program use making a tsunami automatic solution and try to calculate if I have a trip in the area of CATAC. In this case, the program using for the solution, okay, for solution using the source data into the program. For example, using the fall database in Central America, or in bathymetry is data from GetCo. In this case, the solution or the data of the bathymetry is 90 arcoseconds, 30 arcoseconds, and 15 arcoseconds. In this case, okay, in this case, I for this presentation, I introduce artificial events around the zones of Belice and Honduras and Guatemala, and I create this first incident. In the program introduce the latitude and longitude, the events, the dates of the events. I fix in this event with the magnitude 8 and the depth sample 25 kilometers. And after the program calculates of the area structure using Okada, and the program calculate, and in this case the longitude of the area of the structure area using the Okada, and the weight of the area using the 30% of the length of the length of the fold. After the program using the whole database and introduce this data for strike, bit, and rate, and these parameters can introduce manually or after the program obtain solution for the moment tensor of the automatically or manually of if the CATAC receive momentary solution for another agencies. The personnel can introduce the manual solution. After, can introduce the time of the simulation. In this case, introduce 2 hours of the simulation for because if you use the most resolution, the best resolution for obtain the best result of tsunami height for the near area, the program taking more time because of using the best solution bathymetry. In the case, I introduced 2 hours of simulation and using the best bathymetry solution, and generate a patches and start the simulation. And the computer begin the simulation. And as you can see, this solution is very fast because the program using the GPU or accelerated GPU for calculate all solution of the tsunami difference tsunami calculates point calculate to fixings in the 15 and 20 meters of depth, and using the green law to calculate the tsunami height in air. As you can see, the computer finally obtained the solution, and in this case, the time to calculate this solution is 62 seconds, and obtain some information of the forecast tsunami heights in different areas in Central America or area of CATAC. This forecast area is the department division of the country, and can introduce this area for Honduras. Honduras can I say the forecast zones. This area is Atlantida, and Atlantida obtain some information of the 0.5 meters of the tsunami heights for Honduras and other areas around here. The program obtained the information, the text message, and this text message have information of the magnitude, the dates, and the epicenter information, and the arrival time for different areas of forecast areas in CATAC zone, and the tsunami height for this area. This information is the solution of the median of the tsunami height for different tsunami points for each forecast zone. This data can see the compare if to obtain the median's data or maximal solution for this. Can see the difference. For example, the Utila Norte in the median data is 1.71 meters. If you're using the maximal tsunami height, is 2.5 meters. And in this case, what is the preference solution using this median or using the maximal tsunami height? Okay, Japan recommend the data of solution using the maximum tsunami height. But the easy way paper says this data for the medium of the data is the best solution compared using another tsunami model solution, in this case, using no linear formula for tsunami inundation height. This is the idea. I don't know, maybe for the tsunami early information is better using the maximal tsunami high solution, but this is the idea. After it can send this message, this test message using email for a different focal point tsunami of different country, and this information obtained for taking different decisions in the area of the sea. And after, if the information is received for the different agencies, can introduce some information and making another tsunami solution for different time. Solution. Okay.
I'm back. If you have a look to this map and also to the results, it seems they are also getting tsunami already to Panama in this short time, because it tells us here it gets to Cayman Islands, Mexico. So for larger distances, we would have to repeat the simulation for more hours, for 3-4 hours or so.
How long did it take to get to Belize and that?
Yes, it gets to Belize. Here we see it arrives in Panama after 1.5 hours. And why? Because the water in this area here is very deep. Goes first to the northeast, it turns around the shelf area in front of Honduras and Nicaragua, and then it goes to the south, and it very fast it goes to the northern part of Panama. With an amplitude which is, it's 50 centimeters in the 54 centimeters, and that's already a dangerous tsunami. In Honduras, it has 2.5 meters. That's one of the islands. I don't know why this. There should be also for the island of the main island of Honduras, but I don't see it here. So 1.5 meters is very dangerous, and 1 meter is dangerous. 1 meter in Honduras, in Puerto Cortes, it's dangerous for the harbor. And these are in some points, so there might exist other points where the tsunami is bigger. So this we have along one strip of the coast, which has maybe a length of 30 or 40 kilometers. We have maybe 10 points. So in between, there might exist some points where it's higher. So we can say it's above 1 meter. And that's what the color tells us in the colors. So we can also select presentation of the different So whether we want to see the maximum or whether we want to see right in a certain moment. And we can also see very fast the kind of video. We should start in the beginning. It's a little bit slow here in the but you can see it, how the wave propagates, and it's just arriving in Belice. So we don't have, in the moment, you are not included in our generation of products. But if there any interest, it could be very easy. We can also offer, if you are interested to know more about the functioning of this program, we could make a special session with people from you, and we can try different solutions. Here today we used a very, let's say, information which is taken from this fault. So it's a very theoretical data. So it uses the angle of this fault, the direction in which this fault goes, and some data about how is the spatial orientation of the fault and to the depths of the crust of the Earth's crust, and how a fault could be propagating. So in reality, it can be much different. So in reality, it we would take the results of the seismological evaluation of the real occurring fault, and this would depend, how the rupture in the fault is developing. We have made a work about an earthquake which occurred in 2009 in this fault, and it turned out that the epicenter was north of Roatan Island, here where I indicate the cursor, but the strongest movement in the fault was here near the coast of Guatemala, near Puerto Cortes. It was 3 times bigger and faster here. So that means it affected more this area of San Pedro Sula and northern Guatemala than in the original model, which assumed that the strongest movement was here north of Roatan. I was investigating this earthquake with other colleagues, and I was on Roatan visiting the island a few days after the earthquake, and I was wondering why there was no destruction in Roatan. Though there are also houses which are not from the tourist centers, and they are not so well constructed, and they did not suffer big damages. Whereas in San Pedro Sula, I saw the Palace of Justice with big fissures and nearly falling down. And there was a bridge from San Pedro Sula to another city over the river of Sula, which had suffered destruction, though it was constructed by Japanese. That means probably very good construction, and there were damages. So that means in reality, we can have a strange situation, and it's not so, let's say, it's not an easy task for the seismologists on duty to make the first evaluation of the tsunami. It has to be done rapidly. In the beginning, you have to take into account that there might exist a big mistake, a big error, not mistake, but error, because we have very little information. later on, we had more and more data, and the results can be improved. But this might be too late because the tsunami has already arrived in the coast. So this was like an illustration how the work is done. If you have some questions, we can speak about this.
Not much questions, but more comments. We have done, well, we used the commit program
Yes.
to do similar simulations a few years ago when we were doing a pilot project for early warning for tsunamis. We did a similar simulation with a earthquake, pretty much where you had it in that area. I think it's about 8.0 or 8.5 magnitude. Results were pretty similar, that the wave heights, tsunami heights in Belize aren't that high. I think we got about, can't recall, but I think it was less than a meter in the mainland. The waves seem to disperse along the barrier reef.
Yeah.
So much of the energy is lost there. The islands closer to the barrier reef, or other keys, San Pedro Town, and would have been more affected, no? So I don't know if the results here are similar. So I was asking, I didn't see the wave heights for this one for Belize, and the timing. How long did it take to get to the coast?
Yeah, but well, it's simply because we don't have your country in our list of users, and we do not have control points from Belize in our system. We can easily introduce them and repeat it, and to get a better idea.
Sorry, I thought I saw Belize when he did something a while ago. There was a port of Belize.
Yeah, maybe there was sea gauge. Yeah, we are also trying to send out messages in English here. Well, it says in other for Honduras, Belize, Mexico, and so, but I don't see a value of amplitude here. Here, there's one in one station. Yeah, let's do.
Yes, that one. Yeah.
It's really 1 meter. Yeah.
Okay.
Yeah, and yeah, there's another one. The time is actually immediately, because here in this version it takes the arrival is computed for a very small amplitude, it seems.
That's a different location though. The one from the top and the one from the bottom is different location.
Yeah.
I think that one is more to the south of the country.
Yeah.
The idea what this information is to calibrate the solution of the tsunami simulation.
Yeah.
Also using the different data for tidal gauge information to some information so obtain the better solution for the tsunami.
Okay.
And we can also practically enter this menu where we can see, if it's in real time, we can see the data from the sea gauges, so we can observe the level before the arrival of the tsunami, and then it's even possible to correct the prediction. That means the program will take into account the real tsunami wave and would adapt the solution for the tsunami accordingly. We have not much experience with this because we didn't have big events in Central America in lately. So, but it's possible to do this. Yeah. So we get the data from the sea gauges, from the UNESCO system, which has this data center in Belgium. And the data are coming in real time and we can observe them. Yeah. So if we observe while the situation, it's clear that for this earthquake, we will have data only from many stations in the south, that means from Central America, only few seismic stations to the north, that means Yucatan, and nearly nothing or nothing. While we have some few stations in Guatemala, seismic station in Guatemala, where we can get data from. In the moment, the situation in Honduras is very bad. Their network was totally crashing down during the virus problem. They couldn't go to the field. So in the moment, they are trying to reestablish the network. They have about 20 stations from Copeco, and the university should have also around 15 stations. But in the moment, not many are really working. We are getting them, those are working, which are working, we are getting them in our system, but the situation is not so good. So, well, that's what we wanted to show you. If you like, maybe we can think about another meeting. It could be more technical, to discuss details of our system and to discuss how we could get seismic stations into Belize. We would try to organize a project and try to get funding. We have a lot of experience with installation. We could start in the beginning with not the most expensive equipment, which is easy to maintain. And then with more experience, we could think about better equipment. I think you as a meteorological agency would be perfectly able to maintain this. It's not more complicated than meteorological. And all the seismic stations are automatical, and we are even using equipment which were developed by the enterprise I mentioned in the beginning in my work in Panama. So this company was able to produce an equipment which is called Raspberry Shake, very cheap. Thought for enthusiasts, seismology enthusiasts. You can buy it from the cheapest, it's about $200. You can put it in your home and have some recording about earthquakes. For Belize, earthquakes are not a big hazard, of course, but the recording would be interesting for us and for you for the problem of tsunamis. So that's our ideas we have in the moment. Next week, we will have a meeting with CEPRENAC, where we could actually already present some ideas. They have access to money and might help us in this respect.
Okay, so if I may, very interesting presentation. Thank you very much. Indeed, we don't have any seismic stations in the country. It would be very, I think we are open to discussing further how that could be implemented. I was concerned first when you said that Honduras, all their stations went down. So I was wondering if it's high maintenance or if there are stations that require a lot of servicing every so often. Because that would be a problem. We have a network of automatic weather stations that is a challenge to keep running because of that same reason. No? But then you mentioned that the stations are not really that problematic and that they don't require a lot of maintenance. So that is also welcome, because once we install them, of course, we will service them, but we would not want to be out there every month or every week having to service stations.
Yeah.
So that's again, I think that's a very good option, and I think most likely you'd want them on the south of the country, given that the fault line is closer to the south, which is farther from where we are. We are up closer to the Belice city. And in regards to the messages that coming from CATAC, I do speak Spanish. I didn't tell you that, and I do understand Spanish very well. So currently in the format that you have it, I would still be interested in receiving it. If you offer it via WhatsApp, that would be a plus. We get message from the Pacific Tsunami Warning Center, but it's via email, which is not very effective to me, because you're not always checking your email.
Yes.
So getting messages via WhatsApp is definitely a plus. And once we get the message, we transfer it to NEMO, which in our case is the National Emergency Management Organization, and they are the ones who would issue the alert to the public, no? But we are the tsunami warning focal point for the country that disseminate the information to our local emergency management. So one other source of information coming from CATAC, I think would be very useful. And especially in the format, whether it be in WhatsApp, that would be very, to me, effective as compared to email. So that's my input for now. I think we're almost approaching midday, so we may need to wrap up.
Yes.
All right.
Okay. Well, thank you very much. I'm very hopeful. You know, I had already contact with Belice some years ago. Actually, in some meeting here in Managua, I met a former chief of meteorology, and we were near to get a cooperation, but then it somehow disappeared. So I'm very interested to get into contact, and actually I would like to visit you, and definitely I will ask for support to CPNAC, and I'm rather optimistic. What concerns the messages from Hawaii, they are a little bit conservative, because they have so many countries, and to deal with many people in WhatsApp, it's maybe in the moment they're seeing it too complicated. We have only a few customers, you could say, you know, and for us it would be very easy. And the advantage for us would also be that we would know whether people get the message or not. They don't never know whether somebody gets the email or not. They are using a lot the meteorological system, so the WGTS, and they like it because it's very easy. You send out the message and meteorology is distributing it. And they have many contacts with Met agencies, but we less, because in Central America, tsunami warning is more with the seismology departments. And so they do not have the WMO system, and we have to do it by normal email. And everybody tells us the same, yes, it's okay, but we want to have it in our cell phone. So actually, definitely we will do it in this year. We will invest in this and start to send out the messages via WhatsApp, maybe Telegram. Telegram has some advantages in some aspects. Yeah, so I promise. What concerns sending the messages to you, we would do it in the beginning in an informal way. And then it would be necessary to deal with the formal structure of UNESCO. It's possible, but they would help us in this. Okay, thank you very much. Muchas gracias también a Jaika, Chica. Muchas gracias a CPNAC.
Quizás podríamos o pueden enviar la división política de Belice.
intentar meter algunos puntos y comenzar a calcular para Belice.
He's proposing, well, we could start also to have a look to the political division of Belize to have some ideas where we would put the control points for the tsunami warning calculations, but we can see this later on in another meeting, I think.
Yes, certainly.
Okay, muchas
think-
gracias.
Okay.
Your hands up.
Yes, I want to, okay, thank you so much for your participation in the session. We worked a project from 2016 to 2019 with CATAC as a JICA Nicaragua office. And now we are glad to continue working with CATAC. I just wanted to let you know that we have shared a form so you can fill it out, and then we will send a certificate, the recording, and I guess this information will be helpful for future actions that we are considering. I also would like to mention that in this session, we have the participation of a program officer from JICA Belice, which is Marbison. I don't know if she can introduce herself, but she has been participating in the session, and I would like her to introduce herself so you get the chance to know her and realize that we have an office in different countries, and I don't know if they are working together with your institution, but she has been participating in the session.
Thank you very much, Imelda. Thank you, Dr. Strauss. Well, and thank you, Dr. Gordon, and all those are on board. I have been here since the beginning of the session. Very interesting. I am not a Met. I don't know anything about Met services, but I do hear Mr. Gordon very often on the media, on the radio, and we have not really worked a lot with the Met Service of Belize. We work more with MIMO, with Dr. Shelton IV, with Colonel Shelton IV, but we are looking forward, I am looking forward to be able to work more with you, Mr. Gordon. I think today was only the beginning and the introduction of a platform being set for what we can do through JICA in Belize. I want to thank you for your time. I am the program officer for Belize in technical cooperation and any other projects that are presented to our country. And I am very pleased to have had you on board this morning. Thank you so much for your time. And Imelda, thank you for the invitation. I am looking forward to have more communication with Nicaragua's office as we continue working hand in hand. Imelda, thank you. Thank you, Dr. Strauss, for this wonderful presentation you have done today to our country of Belize. Thank you.
Actually, I remember now that I forgot to mention that we have a new CATAC project with JICA, which will permit us to do similar things in the future. So webinars is no problem with Zoom, but also there will be a meeting in Managua in November. And we have also a program to invite people from Belize and Dominican Republic. So it's not only Central America, but we want also that you participate in this project. So somebody from you can come to us and put their hands on the machines and work with the programs and so. And also we can discuss how we are doing the things, and we can learn from you how you are working. And I think it will be very beneficial. This project is for 3 years, starts now in April, I think. April 23, 4, 5 till 26, I think. So yeah, we have something which is helping us to get into better context. Thank you very much.
Thank you for sharing.
Thanks.
Thank you. Okay, I think Susie, she requested me to share that she's been grateful, or she's grateful for the next is grateful for your participation. So we will keep in communication, and we will get your information. So if in the near future you have any questions or you would like to know something else, I think Mr. Strauch is open to future sessions, and we hope to establish more and more communication to see what we can do in the near future together. So thank you for your time, and I hope you have a great lunch. Have a great
Great.
day.
Thank you.
Thank you. All
Thank
right.
you.
Bye-bye.
Bye. Bye-bye.